Hello all. So as a continuation of my lecture series in control systems, in today's topic we are going to discuss impulse and step response analysis of second order system. So in the previous lecture video we have discussed about the impulse and step response analysis of first order system. So till now, under time response analysis, we have discussed about the components, standard test signals, time domain specifications, system stability analysis, and control design methods. And now we are going to continue with second order systems. So introduction to second order system, fundamentals of second order systems, impulse response of second order system, step response, and RLC circuit as second order system. So basically, so as we have already discussed, all these topics are very important in electrical engineering because we have many real world electrical problems in power systems, in circuits and in drives. Whereas oscillation is the main part of problem in power system, and resonance makes the main part in filter circuits, and transient response in switching circuits. All these plays a major role in the electrical applications. And what is the impact if not solved? So basically all these are done in order to prevent system instability, component damage and signal distortion. All these plays a major role in electrical problems nowadays. So coming to the need for the solution, so limitations of existing methods like complex calculations, oversimplified models which ignores nonlinear effects, and computational complexity for multivariable systems. And what are all the technological gaps? Like already we have discussed, lack of adaptive analysis tools. So still we have to improve the tools in higher level in order to avoid hardware implementation and negative results. Insufficient real-time response evaluation and limited integrated simulation platforms. And coming to fundamentals of second order systems. So the definition and characteristics is the system with two energy storage elements characterized by second order differential equations, and it has two poles in the transfer function. So this is the difference between the first order and the second order system. In transfer function, second order system, it is omega n square plus s into omega 2s omega n s plus omega n. So this will make the transfer function of second order system, where omega n is the natural frequency and del is the damping ratio. So based on the del value, it has four effects, which is undamped, underdamped, critically damped and overdamped. So these plays a major role based on the value of eta. Like when del is equal to 0 and it is undamped and it gives continuous oscillations. So when del varies from 0 to 1, it is called as underdamped and it is oscillatory. And when del is equal to 1, it is critically damped, and when del is greater than 1, it is overdamped and the response will be very slow. And in the right side of the graph, we have shown all the four effects and its graphical representation. So coming to impulse response of second order system, the mathematical derivation and its equation and how it gives the time response. When we go with inverse transform, then it gives the time domain response. And the response equations for when del is equal to 0, del is equal to 1 and 0 to 1 and greater than 1. Coming to step response of second order system. So the mathematical equation which we have considered is omega n square by s into s square plus 2 del omega ns plus omega n square, whereas the input is r of t, and when we take Laplace transform it becomes 1 by s. And we go with partial function and inverse transform again in order to make c of t. And the key parameters are rise time, peak time, settling time and overshoot. So settling time is something when the graph becomes a constant value. So rise time is initially when it goes from 0 to the maximum value, and peak time is the highest peak which the characteristic touches. So the response characteristics is undamped when it is continuously oscillated and underdamped when it is oscillatory. Coming to RLC circuits as second order systems. So RLC circuit, the equation is 1 by LCS square plus RCS plus 1. Similar way, the natural frequency, damping ratio and damped frequency are taken, which is omega D. Then we have a particular formulas in order to analyze the particular transfer function is under the stable condition or what. So coming to the summarized part, in this lecture we have discussed about the second order systems and the step response, impulse response equations, and how to make it as a time response equation and RLC circuits. Thank you.